This topic is about measuring the spread of data by calculating the variance or the standard deviation. So ideally, we'd like to measure the spread of data by linking it to every value in the data set. So obviously, interquartile range does not take every value into account because we disregard the outliers. Range takes maximum and minimum all into account, and interpercentile also ignores some values. So what we need to do is find a way of incorporating every single data point into this calculation. So this is done by considering the relationships between each data point and the value of the mean. So for the set, so what happens is if you have, for example, numbers x1, x2, x3, and then we have calculate x bar, which is going to be somewhere in the middle, possibly x5. So what we're doing is we're finding the distance that every point is from the mean and working out basically the average of that. So for the set of data below, calculate the mean and then the deviation between each value and the mean. So first thing I need to work out is x bar, which is mean. So x bar will be equal to 17 plus 12 plus 15 plus 13 plus 16 divided by 5, which is equal to 14.16. So 14.6. So x bar is equal to 14.6. So next thing we need to do is find how to calculate the mean. We've calculated the mean, then we need to find the deviation between each value and the mean. So that means the difference between each value and the mean. Okay, so 17 minus 14.6 gives me 2.4. 12 minus 14.6 gives me negative 2.6. 15 take away 14.6 gives me 0.4. 13 take away 14.6 gives me minus 1.6. And 16 take away 14.6 is 1.4. So these are the deviations between each value and the mean. So just each data point take away the mean value. So it doesn't matter that some of the values are negative, we're going to square it. So when we square it, all the obviously negative numbers will become positive. So when we want to work out variance, which is equal to sigma squared, so be very careful. So variance is equal to sigma squared. It's the sum of all these deviations squared divided by n. So what that means is it's a sum of, so what we need to do is we have to do 2.4 squared plus minus 2.6 squared plus 0.4 squared plus negative 1.6 squared plus 1.4 squared divided by the number of data, which is equal to 5. Now when we work this out, we get 3.44. So that would be the variance. Now to work out the standard deviation, what we do is we square root the sum of the deviations and then divide by n. So if I were to do that, it will be square root of 2.4 squared plus minus 2.6 squared plus 0.4 squared plus negative 1.6 squared plus 1.4 squared all over 5. Just be very careful, the square root is for the whole thing, yeah? So the 5 in the denominator is also underneath the square root. Okay, which means if I put this into my calculator, I get 1.85472 going on forever, which is equal to two decimal place, it will be equal to 1.85. And when you square 1.85, you get 3.44. So variance is a measure of the spread of data, which is obviously the unit, whatever units the data has been measured in is a unit squared. Standard deviation is in the same unit as the data set, and you have to square root the variance to get standard deviation. So the key things to remember is variance is measured as denoted as sigma squared, and standard deviation is just sigma. Now there's not just one version of the formula, there's another version of the formula. So let's look at that. So sigma is equal to, according to our formula, is equal to sum of the deviations from the mean squared divided by n. Now if we expand the bracket, that is the same thing as sum of xi squared minus, we're going to get 2 lots of sum of xi times x bar plus x bar squared all over n. So make sure the square root is included in the denominator. Now the key thing to remember is if we are doing sum of x over n, that is the same thing as x bar. Okay, since sum of xi over n is equal to x bar, then what we end up getting is, when we simplify it, is sum of xi squared minus 2 lots of x bar squared plus x bar squared all over n. Now minus 2 lots of x bar squared plus x bar squared just gives me us x bar squared. So that the last two terms simplify to x bar squared all over n. Now x bar squared, I should have had sum by the way everywhere. So let's just include sum of x bar. 2 lots of, let's go back, include the summation. Sum of x bar squared minus sum of x bar squared. So there was a summation here. Now the sum of x bar squared is just n lots of x bar squared. So the n will cancel out with the denominator. So all we end up getting is sum of xi squared over n minus x bar squared. Okay, which is just, in another form, is sum of xi all squared over n minus x bar is just sum of xi over n all squared. So this is how we get the two different versions, which is the second version and that version. The numerator of the fraction in the formula is the sum of the square deviations from the mean and is denoted S of xx. So S of xx is the sum of square of the deviations of x values from their mean. So it's equal to, basically, let's just use a different color. That there is just S of xx. So the sum of the square of the deviations of x values from the mean. So that is just sum of xi minus x bar squared. So we can write sigma as square root of S of xx over n. And that's another version. So let's highlight that one. So that's another version of the formula. Okay, the key thing is the smaller the value of sigma, the more consistent the data is. So, because obviously everything's scattered around the mean, that means. Okay, so smaller the value of sigma, the more consistent the data is. Let's go through some examples. Okay, so a set of sample data is summarized as n is equal to 100, sum of x is equal to 1420, and sum of x squared is equal to 22,125. Find the mean. So x bar is equal to sum of x over n, which is equal to 1420 over 100, which just gives you 14.2. Part 2, standard deviation. So standard deviation, remember, is just sigma, not sigma squared, that's variance. So it's equal to sum of x squared over n minus x bar squared. So I'm going to use the last version that we had here. So that one, I find that version easier. So because I've already calculated the mean. So it's going to be square root of 22125 over n, which is 100, minus 14.2 squared. So when I put this into my calculator, I get 4.428317, blah, blah, blah. and I round this to 2 decimal places, I get 4.43. A corner has 8 pigs. The sum of their ages is 18 years. So sum of x is equal to 18. The sum of the squares of the age is 55. So sum of x squared is equal to 55. And n is equal to 8. Find the mean, standard deviation, and variance of the age. So mean is x bar, which is sum of x over n, which is equal to 18 over 8, which is 2.25. Standard deviation is just sigma, which is square root of sum of x squared over n minus x bar squared, which is equal to square root of 55 over 8 minus 2.25 squared, which gives us a value of 1.346291. And when rounded, this will be 1.35. Variance is sigma squared, which is just sum of x squared over n minus x bar squared, which is just 55 over 8 minus 2.25 squared, which is equal to 1.8125. Next question. The following are the marks of Asma, Brian, Charles, Dorota in 5 tests. Who has the most consistent set of set of marks, sorry. So Asma, let's do that one first. So I'm going to work out the standard deviation. So sigma is equal to square root of 12, sum of x squared. So it's going to be 12 squared plus 8 squared plus 17 squared plus 18 squared plus 15 squared all over 5 minus the mean squared. So mean is just 12 plus 8 plus 17 plus 18 plus 15 all over 5 squared. Now when I put this into my calculator, I get 3.633180425, which rounds through 3.63 to 2 decimal places. So Brian, similarly, sigma will be equal to square root of 15 squared plus 14 squared plus 5 squared plus 20 squared plus 16 squared all over 5 minus 15 plus 14 plus 5 plus 20 plus 16 all over 5 squared. I end up getting 4.939635, which is equal to 4.94. So the higher the standard deviation, the less consistent it is. See? So sigma will be equal to 14 squared plus 14 squared plus 20 squared plus 8 squared plus 14 squared all over 5 minus the mean squared, which is just 14 plus 14 plus 20 plus 8 plus 14 all over 5 squared. And I get the value 4.9, nope, that's not correct. I get the value 3.794733, which gives me 3.79 to 2 decimal places. The last one, Dorota, is equal to sigma is equal to square root of 12 squared plus 19 squared plus 9 squared plus 14 squared plus 16 squared all over 5 minus the mean squared, which is 12 plus 19 plus 9 plus 14 plus 16 all over 5 squared. I end up getting 3.40587 blah blah blah, which is 3.41. So which one is the smallest? 3.41 is the smallest. So Dorota is most consistent as sigma as her standard deviation. is smallest. A set of data has mean of 21, so x bar is equal to 21, and standard deviation of 12, so sigma is equal to 12. New data values of 18 and 24 are added, and the mean and standard deviation are recalculated. Without carrying out any calculation, explain how the mean and the standard deviation change, if at all. Okay, so mean is 21, so the mean is unchanged. Now, what is the reason behind that? The average of 18 and 24 is 18 plus 24 divided by 2, which is equal to 21, which is the same as the original mean. So therefore it remains unchanged. So it's just like adding 2 lots of 21 on. Now the standard deviation will decrease. And what is the reason behind that? Let's calculate. Will decrease. As if we work out the mean deviation from the mean, then we get 18 minus 21 squared, which is 9. And we get 24 minus 21 squared, which is just again 3 squared, which is 9, which is less than the original standard deviation of 12. Okay, a set of 15 numbers has mean 7 and standard deviation 4. So x bar is equal to 7 and sigma of x is equal to 4 and number n is equal to 15. Okay, a second set of 25 numbers has mean of 9, so let's just call it y bar is equal to 9. Sigma of y is equal to standard deviation is 5 and n is equal to 25 here. What is the standard deviation of the combined set of 40 numbers? Okay, so we need to combine these together. So first of all, mean x bar is equal to sum of x over n, which means that we get x bar is 7 must be equal to sum of x over 15, which means sum of x must be equal to 15 times 7, which is equal to 105. Now sigma of x is equal to square root of sum of x squared over n minus x bar squared, which means we end up getting 4 is equal to square root of sum of x squared over 15 minus 7 squared, which means when we rearrange this, we end up getting sum of x squared will be equal to, first we have to square 4, so we get 4 squared, then we have to add 7 squared, and then we have to times by 15, which means sum of x squared will be equal to 975. Okay, now we need to do the same thing with y. So y bar will be equal to sum of y over n, which means 9 is equal to sum of y over 25, which means sum of y is equal to 9 times 25, which is equal to 225. Sigma y is equal to square root of sum of y squared over n minus y bar squared, which is equal to sum of y squared, which implies sigma of y is just 5 must be equal to sum of y squared over 25 minus 9 squared. So if I rearrange it, first I need to square it, so sum of y squared will be equal to 5 squared plus 9 squared and times by 25, which implies sum of y squared is equal to 2650. Now I need to find the new standard deviation. So new standard deviation of combined set is equal to sum of x squared plus sum of y squared over total, which is 40. Combined set of 40 over 40 minus sum of x plus sum of y over 40 all squared, which is the same thing as 975 plus 2650 over 40 minus 105 plus 225 over 40 all squared. I put this into my calculator, I end up getting 4.75. Variance and standard deviation for frequency tables. So x bar is obviously for a frequency table becomes sum of f of x over sum of f. So sigma squared will become sum of f of x squared over n, which is sum of f, if I write sum of f, minus x bar squared. That's the version that we prefer. You can also write this as sum of f of x squared over sum of f minus sum of f of x over sum of f all squared. The other way of thinking about it, the initial version that we came across is sum of x, f times x, I minus x bar all squared, all over sum of f. But that's the version we don't prefer to use, but you can if you want to. Similarly, if you want to do standard deviation, it's just the same thing with the square root. So it'll be sum of f of x squared minus over sum of f minus x bar squared, which is equal to square root of sum of f of x squared over sum of f minus sum of f of x over sum of f all squared. Similarly, equal to square root of sum of f xi minus x bar all squared over sum of f. Let's go through some examples. So the table below shows the number of occupants of each house in a road. Find the standard deviation of the number of occupants. Okay, first thing I want to work out is, because I need x bar for standard deviation, I might as well work out x bar. So x bar, which is mean, is equal to sum of f of x over n, which means all I have to do is, this is x and this is f. Because it's discrete data, I just need to multiply it and add it together and divide by n. So it's 1 times 2 plus 2 times 5 plus 3 times 6 plus 4 times 10 plus 5 times 8 plus 6 times 1, all over this total frequency, which is 2 plus 5. I prefer writing sum of f. 2 plus 5 plus 6 plus 10 plus 8 plus 1, which is equal to 29 over 8, which is 3.625. We want to find the standard deviation, which is sigma, which is square root of sum of f of x squared over sum of f minus x bar all squared, which is equal to square root of sum of f times x squared. Okay, so it's going to be 2 times 1 squared plus 5 times 2 squared plus 6 times 3 squared plus 10 times 4 squared plus 8 times 5 squared plus 1 times 6 squared, all over the total frequency, which is equal to 2 plus 5 plus 6 plus 10 plus 8 plus 1, minus x bar squared, which is 3.625 all squared. In our calculator, we end up getting 1.268611. When rounded to 2 decimal places, this is 1.27. Okay, next one. This is a group frequency table, so we need to work out the midpoint. So in this example, the mid-interval value has already been worked out. So this is a x and our frequency is f. Estimate the sample mean and the standard deviation of the data with the following frequency distribution. So again, sum of x bar is equal to sum of f of x over sum of f, which is equal to 4 times 5 plus 6 times 15 plus 9 times 25 plus 7 times 35 plus 4 times 45, all over the frequency, total frequency, 4 plus 6 plus 9 plus 7 plus 4. I get a value of 25.3 recurring from our calculator, which means it's 25.33 to 2 decimal places. Now sigma is equal to sum of the square root of sum of f of x squared over sum of f minus x bar all squared, which means it's going to be 4 times 5 squared plus 6 times 15 squared plus 9 times 25 squared plus 7 times 35 squared plus 4 times 45 squared, all over sum of f, which is 4 plus 6 plus 9 plus 7 plus 4. Take away the mean, which was 25.3 recurring, all squared. And in the calculator, we end up getting 12.24291178, which is equal to 12.24 to 2 decimal places. Now you can use your calculator to check your answer and calculate it easily. So first thing you need to do is go to menu, then press 6 for statistics, and then 1 for one variable calculations. Then you need to input data with x being the midpoint. Always for continuous data or when you have a group frequency table. Then you press option, then press 3 for one variable calculations. Okay, I think this one was just one variable. And then you go to, then you get a list, and what you're looking for is sigma of x, which will be 12.242. It should be the same number. So if you want to use your calculator to work it out, this is how you do it. The next one, the group frequency table shows the length of service in years of employees who have been working for a company for at least 10 years. Calculate an estimate of the standard deviation of the length of service of these employees. So first thing I would do is write down the midpoint. So just check, because sometimes the class intervals are different. So 22.5 here, 27.5 here. Look at the last two, you can see they're of different class widths, so be very careful. Okay, so x bar is equal to sum of f of x over sum of f, which means it's going to be f times x, so it's 30 times 12.5 plus 42 times 17.5 plus 23 times 22.5 plus 13 times 27.5 plus 8 times 35 plus 4 times 45, all over the total frequency, which is 30 plus 42 plus 23 plus 13 plus 8 plus 4. Now from our calculator, we end up getting 20.375. Okay, we need this number to work out the standard deviation. So the standard deviation is equal to sum of f of x squared over sum of f minus x bar squared. I didn't need to make that long. Which is equal to 30 times 12.5 squared plus 42 times 17.5 squared plus 23 times 22.5 squared plus 13 times 27.5 squared plus 8 times 35 squared plus 4 times 45 squared, all over sum of f, which is 30 plus 42 plus 23 plus 13 plus 8 plus 4, minus the mean, which is 20.375 all squared. We end up getting 7.696387, which is 7.70 to 2 decimal places. Now some problem solving questions. An adult evening class has 14 students. The ages of these students have a mean of 31.2. So x bar is equal to 31.2. Standard deviation is equal to 7.4. And n is equal to 14 in this case. A new student who is exactly 42 years old joins the class. Calculate the mean and the standard deviation of the 15 students now in the group. Okay, so we have x bar is equal to sum of x over n, which implies x bar is 31.2 is equal to sum of x over n, which is 14. So sum of x must be equal to 31.2 times 14, which is equal to 436.8. So the total of the first 14 students, the sum of their ages is 436.8. Okay, if I use sigma x, if I work out sigma is the formula for sigma to work out the standard deviation is equal to sum of x squared over n minus x bar squared, which implies 7.4 is equal to square root of sum of x squared over n, which is 14, minus mean, which is 31.2 squared. Now, if I rearrange to find sum of x squared, then sum of x squared, first thing I need to do is square 7.4 squared, add it to 31.2 squared, and times it by 14. Sum of x squared will be equal to 14394.8. Now I need to work out the new sum of x will be equal to the old sum of x, which is 436.8 plus 42, the new plus 42, which is equal to 478.8. Okay, new sum of x squared will be equal to the old one, so the original one, sum of x squared, which is 14394.8, plus the 42 squared, which is 16158.8. So if I want to calculate the new mean, so new x bar will be equal to new sum of x over new n, which is 15, because if you add one more student. So it's going to be 478.8 divided by 15, which is equal to 31.92. And the new sigma will be equal to the square root of the new sigma squared over sigma x squared over 15 minus the new x bar squared, which is 16158.8 divided by 15 minus 31.92 squared, which is 7.63982, which means we get 7.64. The weight in kilograms W of 15 players in a rugby team was recorded and the results summarized as follows. Sum of W is equal to 1145.3. Sum of W squared is equal to 88042.14. A. Calculate the mean and the variance of the weight of the players. So mean is equal to x bar, which is equal to sum of W over n. Sum of W is 1145.3 divided by n, which is 15, which is 76.353 recurring, which is equal to 76.35 to 2 decimal places. Variance is sigma squared. Be very careful. So variance is sigma squared, which is equal to sum of W squared over n. minus x bar or w bar. I should have called it w bar. Minus w bar squared, which is equal to 88042.14 divided by 15 minus 76.353 recurring, so the non-rounded version, squared. So what we end up with is 39.64448, which is equal to 39.64. Due to injury, one of the players who weighed 79.2 kg was replaced with another player who weighed 63.5. So the weight has gone down. Without further calculation, state the effect of this change on the mean and the variance of the weight of the players in the team. Explain your answer. So B, mean will be lower. Mean will decrease as 63.5 is less than 79.2. So it will make total weight lower. So the mean was 76.35. So what will happen to the variance? So variance will increase as 63.5 is further away from the mean. So the mean is 76.35. 79.2 was closer. So 63.2 is a lot further away. So most likely the variance will increase. So it'll go higher. The data is more spread out because it's gone further away. That one data point has gone further away from the mean. Okay, a company offering a bicycle courier service within London collected data on the delivery times for a sample of jobs completed by staff at each of its 2 locations. The time T minutes for 20 deliveries handled by the company's Hammersmith office was summarized by sum of T is equal to 47 and sum of T squared is equal to 11,077. Find the mean and the variance of the delivery times in this sample. So A, first thing is mean. So T bar is equal to sum of T over N, which is 427 over 20, which is equal to 21.35. And then variance, which is sigma squared, so be very careful with that, is sum of T squared over N minus T bar all squared, which is equal to 11077 over 20 minus 21.35 squared, which is equal to 98.0275. The company's Holborn office handles more business, so the delivery times for a sample of 30 jobs handled by this office was taken. The mean and the standard deviation of this sample were 18.5 and 8.2 respectively. Find the mean and variance of the delivery time of the combined sample of 50. So now we have, let's call it S. So S bar is equal to 18.5. And we have sigma of S is equal to 8.2. N is equal to 30. So that means we need to find out using the formula. So S bar is equal to sum of S over N, which implies 18.5 is equal to sum of S over 30, which implies sum of S is equal to 18.5 times 30, which is equal to 555. Using the formula for variance, sigma of S is equal to sum of S squared over N minus S bar squared, which implies 8.2 is equal to sum of S squared over N, which is 30 it was, for this new set of data, minus S bar is 18.5 squared. Now if I rearrange this, I get sum of S squared is equal to 8.2 I just realized it was standard deviation, so be very careful, read the question carefully. Standard deviation, it wasn't variance. Although the original question was about variance, I've got square root here everywhere. So that means I get 8.2 squared plus 18.5 squared times by 30, which is equal to 12284.7. So if I want to work out the new mean, it's going to be the total sum of S, so sum of S plus sum of T all over the total number of jobs, which is 50, which is equal to sum of S is equal to 555 plus 427 over 50, which is 19.64. And new variance we want is equal to sum of S squared plus sum of T squared over 50 minus this new mean, which is 19.64 squared, which is equal to sum of S squared is equal to 12284.7 plus sum of T squared, which is 11077 over 50 minus 19.64 squared, which is equal to 81.5044, which is equal to 81.50. That's it. So the key thing to remember here is make sure you read carefully which one you have in front of you. Is it standard deviation or variance? Because that's going to be a mistake that you can easily make in an exam.